scientific notation for large numbers. So what we've got here is a way to write very, very big numbers in a standard form, which makes them easy to compare and easier to write, actually. We can use less digits to write them. Now, scientific notation for small numbers we'll learn in a future lesson, but right now let's just concentrate on the large numbers. I think it makes sense to separate them. In the past, I've taught them at the same time, and people get confused. But let's just concentrate on large numbers right now. We'll throw small numbers into the mix later, and everything will make a little bit more sense that way, I think. Okay, let's write 2.5 times 10 to the 6th with digits. In other words, we're going to make it look like this. This is scientific notation down here. 2.5 times 10 to the 6th. Here we go. Just looks like this. 2.5 times 10 to the 6th. That is scientific notation, people. Okay. We're always going to have a number that is greater than or equal to 1 right here. It's always going to be less than 10, though. So it's going to be a 1 through a 9 right here, and you may or may not have a decimal. And then it's always going to be multiplied by 10 to some power. That power could be anything. In fact, it could be 0 or it could be negative. But today we're just dealing with positive exponents. And we're going to use words to write this number that is in scientific notation. We say this or write it as 1.8 times 10 to the 8th. All right, so 1.8 times 10 to the 8th. Scientific notation, and that's how you say it. So what we have here is we've got 4 numbers. They're all written in what we call standard form. Okay, we're going to write them in, these are all written in scientific notation. We're going to write them in standard form. Standard form is the form you're used to. So 2.0 times 10 to the 5th. So that's like 2.2, it's 2 times 10 times 10 times 10 times 10 times 10. So basically, we need to move this decimal 10 spots to the right. So move it once, twice, 3 times, 4 times, 5 times. We're done. We'll just throw a comma in there to organize it. And that comma is important. Well, keeps things organized for us. But so we move that decimal. It used to be right here. We moved it 1, 2, 3, 4, 5 times. Okay, so 7.5 times 10 to the 8th. We're going to move that decimal over 8 times. And remember, we're representing large numbers. And if you multiply something by 10 to the 8th, you're multiplying it by, a very, very big number. Multiplying something by 10 8 times. Okay, so we're going to move that decimal place. Ready? Once, twice, 3 times, 4 times, 5, 6, 7, 8 times. Okay, now we're not adding 8 zeros. We actually only added 7 zeros, but we moved the decimal place past the 5 as well, so that was the 8th place. Let's do this again. 1.609 times 10 to the 3rd. Move that decimal place 3 spots. 1, 2, 3. Boom. Done. 1.609 times 10 to the 3rd is 1,609. And lastly, 3.05 times 10 to the 4th. We're going to move this decimal place 4 spots. It's like multiplying it by 10,000. So here we go. Move it 1, 2, 3, 4 spots. Throw a comma in there to organize it. All right. So that's going from scientific notation to standard notation. On the next slide here, we're going to go from standard notation. These are in standard notation, and we're going to write it in scientific notation. Okay, so I know that I want this to be 3.65. The question is, what power of 10 am I multiplying by? Okay, so to get that decimal place right here between the 3 and the 6, how many places would I have had to move the decimal? 5 places. That's it, 3.65 times 10 to the fifth. Remember what I said about scientific notation too. You're always going to have a number between 1 through 9 right here, then a decimal point, and you may or may not have a decimal part. And it can be 1 digit, 2 digits, it can be 5 digits, however many digits you need. All right, 295 million. It's going to be 2.95 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 2.95 times 10 to the 8th. Okay. Again, on I, we want to move this decimal place right here. So we're going to write this as 7.05. You got to keep everything that isn't a 0, and it's times 10 to the 4th. Okay, I said keep everything that's not a 0. We have to keep this 0 that's between two non-zero numbers, but we're going to drop the zeros off the end. Drop the zeros off the end. Drop the zeros off the end. Zeros in the middle we need to keep. All right, 25 million. First of all, let's write that in standard notation. Here's 25 million. So we're going to write that as 2.5 times 10 to the 367. Okay, so that's how you write numbers in scientific notation. We're going to work on this over several problem sets. You're going to get better and better at it. You're going to make mistakes from time to time, but then we're going to make corrections and learn from our mistakes. That's all I've got for you today. Have a great night.